This is Mrs. Phelps. We're going over section 2.4 on completing the square today. And to start, we're going to go over some review type problems and then see how this ties into the process of solving a quadratic by completing the square. And then we're also going to look at the algebra tile approach. So we looked at that briefly a couple weeks ago when we started factoring. So we're going to go back to looking at that with what it means to complete the square. So to start, you can go ahead and pause this video and try the first 5 problems. So that's all of these in here. So I recommend that you pause the video, try solving those, and then come back. And then I'm gonna go over them, or you can just skip through this part of the video if you got the answers correct. So if we have x squared equals 9, we want to take the square root of both sides, but remember when you take the square root of a number, it's positive or negative, because positive 3 times positive 3 is 9, or negative 3 times negative 3 is 9. So make sure that you got positive or negative 3. And then for part B, we can bring the 5 to the other side. So we have x squared equals 9, and then because this is x squared by itself, we can again take the square root, you get the same result. Another way that you could do A or B is to bring everything to one side. So for A, you might have done x squared minus 9 equals 0, and then x plus 3 times x minus 3 equals 0, difference of squares. And then you'd still get plus or minus 3. So you can do it either of those two ways. And for part C, so if you did x minus 3 times x minus 3, then you'd see it's just x equal to positive 3. Or if you took the square root of both sides, then you'd just get x minus 3 equals 0. Plus or minus 0 is just 0, so x is only equal to 3. And you could try negative 3. If you plugged in negative 3, you'd get negative 3 minus 3 is negative 6 squared. That would not be equal to 0. And then this problem is a try this. I'm going to go over it though, so just make sure that you do your try this problems on Schoology. That's worth a good percentage of your grade. So here we have the square root of, we can take the square root of both sides since this whole quantity on the left side is squared. And when you do that, we get x minus 3 equals plus or minus 2. The other way that you could do this, and some of you probably did it this way, is actually multiplying out x minus 3 times x minus 3. And this process is a lot longer, so this would get you x squared minus 6x plus 5 equals 0, and then you could factor it, and you'd get the same results. So 3 plus or minus 2, that's 3 plus 2 is 5, 3 minus 2 is 1. And if you factored it from here, then you would get the same results. And so the idea is you're seeing that when you have a whole quantity squared on one side, taking the square root can be a lot more efficient. So for part D, this is a perfect square trinomial, and I know that because the first term is a perfect square, so is the last. That's x squared, this is 5 squared, and that middle term is 2 times the square root of the first times the square root of the last. Or if you have trouble remembering that, you can always factor it how we normally would. 2 numbers that multiply to 25 and add to 10. That's positive 5 and positive 5. So we get x plus 5 times x plus 5 equals 0, or x plus 5 squared equals 0. And either way, just like we did in part C, you're going to get x equals negative 5, and that's it. So for number 2, it says, notice this problem looks very similar to 1e. That's a typo, I need to fix that. So it should say 1d. And so prior to this lesson, we've always put the equation in standard form prior to solving. But my question is, what if we don't do that here? So try solving this without putting it in standard form first. So see what you can do with the left side, like we did in the first try this problem. See what you can do there and see if you can get to the answer. I recommend that you pause this and then continue watching. See if you got the right answers. So since this is a perfect square trinomial, we already factored it in part D. We said that this is x plus 5 squared equals 16. So it's the same problem as part D, except instead of being equal to 0, it's equal to 16. So the idea here is if you can get this quantity on this side so that the whole thing is squared, then we can get rid of that square by taking the square root of both sides. So that's x plus 5 equals plus or minus 4. And then we get x equals negative 5 plus or minus 4. So x equals negative 9 and x equals negative 1. So these answers are different from part D because part D it was equal to 0. Here it's equal to 16. So again, the idea is you could bring this 16 to the other side and we'd be left with x squared plus 10x plus 9 equals 0. And then we can factor it and we'd get the same results. But as we go into these next problems, we're going to see that this actually shows us a process where it's different than factoring, and it'll make it so we can solve some problems that would not normally be factorable. So number 3, it says what can we do to these quadratics to be able to factor it as we did in number 2. And if you get a radical in your solution, so that's when you have a square root, so like the square root of 7, then we're going to simplify it but leave it as an exact solution. So what that means is if we had the square root of 12, that can be simplified. You can take out a 2 because that's 4 times 3, so take out a 2, that would be 2 rad 3. So you want to simplify radicals, but you don't want to actually put that into a calculator to get a decimal. If you leave it like this, it's called an exact solution. And then you don't have to worry about the checking your homework because I'm going to make an answer key for it. But okay, so part A, the question here is what can we do to make it so we can factor it like we did in number 2. So in number 2, we were able to go x plus 5 squared equals. And we were able to do that because two numbers multiplied to 25 and added to 10, but we don't have a 25 here. So the question is, what can we do to both sides to make it so that we have 25 here? So go ahead and pause the video, think about that. So what can we do to make 22 25 instead? So if you came up with adding 3 to both sides, you are correct. So you can add 3 to both sides, and that makes it so that the equation is still true. And if I add 3 to both sides, now I have that same left side as we did in number 2. So now we have x squared plus 10x plus 25 equals 9, which means that we can factor it to x plus 5 squared equals 9. And then because we did this, we can take the square root of both sides. We get x plus 5 equals plus or minus 3, which is negative 5 plus or minus 3, and that's negative 8, and x equals negative 2. So again, rather than factoring this, x squared plus 10x plus, and then bringing the 6 over, and then you could go x plus 8, x plus 2. So this works. But rather than factoring it, we're trying out this other method where we get a quantity on one side so that it's squared, and then we can take the square root of it. And this is going to be useful when we get to stuff that you can't factor. So this one was nice. You could just factor it to x plus 8, x plus 2. But they're not all going to be like that. So let's look at part B. Let's say that we did decide to just factor it. So if we went x squared plus 10x and then plus 13 equals 0. So if I brought the 17 over. So you're looking at that. What two numbers multiply to 13 and add to 0? Well, there are none. So in chapter 1, we would just say that this is prime. But now we're using a method that will allow us to solve any quadratic. There's no such thing as prime anymore. Prime means that you don't get integers or any sort of fraction as your solution. Instead, it's irrational numbers, but you can get irrational solutions when you complete the square. So, and that's what we're going to be going into. So here we have x squared plus 10x plus 30 equals 17. So again, I want to get it so that we have x squared plus 10x plus 25. So that way we can go into getting the same factor twice. So to do that, if we subtract 5 from both sides, now we have this quantity on the left side that can be written as x plus 5 squared equals 12. So take the square root of both sides, and as you can see, the left or the right side, we don't know the square root of 12. So when we had the square root of 9 in part A, we were able to write that as plus or minus 3. But this is where you see that you're not going to always get nice numbers as your solutions. So here we have x equals -5 plus or minus the square root of 12. And I already did the square root of 12 over here on the left side. So again, it's that's 4 times 3, and 3 is 2 times 2. Since we have a pair of 2's, we can take out a 2. So this is -5 plus or minus 2 square root 3. And this is our answer. You can write it as -5 plus 2 rad 3 and -5 minus 2 rad 3 if you prefer that, but you don't need to write it like that. And again, this is called an exact solution. So you want to keep it as an exact solution. If you were to multiply out 2 rad 3 and then add that to -5, multiply out 2 rad 3 and subtract that from -5, you would get the decimal answers for it. But we don't want to be doing that. We're going to keep it as exact solutions. Okay, so number 4, this one's slightly different. It says try to put them in the same form as we did above before solving. So here we have, instead of x squared plus 10x, we have x squared minus 10x. So the question here is, in order to get the same thing twice, that's our goal, is to get some quantity squared so that we can take the square root of it. What does this last term need to be so that we can do some quantity squared? So the idea here is, what does this c value need to be so that we can have one quantity, so the binomial squared? So in the last couple problems, we had positive 10x, which made it so that our factors were x plus 5 and x plus 5. So what do we need in order to get -10 when we add these two terms together? And then what is that going to make it so that we get for that last term? So instead of positive 5, we want -5, -5. That'll give us -10x for the middle term. And then -5 times -5 is still positive 25. So we still have that same c value. C is always going to be positive in order to get the same quantity multiplied by itself. But here it's x minus 5 so that we can get the -10x. So what did we add to get 25 from 21? That was plus 4. So I'm going to add 4 to the other side. So now we have a quantity squared equal to just a constant on the right side. So because this is the whole quantity squared, we can square root it, and we get x minus 5 equals plus or minus the square root of 7. 7 is prime, we can't simplify it anymore, so we can just bring the 5 over. 5 plus or minus the square root of 7. And these are our two answers. Okay, go ahead and try number 2. And you're going to want to come up with, what do I need to add to get to a value here? So that way I can write it as some quantity squared. So you can work backwards for this. So if you need a total of 6x, think about what these two terms need to be, and then what this c value needs to be. And remember, you can always check the answer key after to make sure that you got this right, or when you're doing the try this problems, you get your 3 attempts and it'll show you the correct answer, so you can check that. All right, that is it for the first half of this lesson. So go ahead and start watching the next one when you're ready. This is just kind of an intro to where completing the square comes from. And then we're going to be going straight into some more of that. So see you in a minute.